Okay, now permutation. So the definition of permutation is basically from n different objects, we choose k without repetition and order matters. Let's say I have five alphabets, um, A, B, C, D, E, and let's say I choose three of them out. Okay, so it can be A, B, C, it can be C, D, E, it can be A, C, E, it can also be B, D, E. So out of the three objects, we can choose these, right? Order matters. What does it mean? So basically, BDE and BED, they are different, and also DEB, they count as different different arrangements, basically. So how do we come up with a formula that describes from the n different objects, choose k without repetition, order matters? How do we do that? So firstly, let's look at the notation first. So permutation, of course we denote it with big P, and then from n different objects we choose k. Okay, so Pn choose k basically, and it doesn't matter where you put your n and k. Well, it does matter, but these are all the possible arrangement that you might encounter. They describe the same thing. They're the same operation. From n different objects, choose k without repetition. Yeah. So the formula is n factorial over n minus k factorial. Now, how does this make sense, right? Let's say again A, B, C, D, and E, and I choose three objects, or I choose three out of this five. So there's only essentially there's only three blocks, right? And out of these three blocks, we have the first block, we have five options: A, B, C, D, and E, right? And for the second one, after choosing one, we only have four options left. So 4, then 3, and that's it. And you times them together, you multiply them together. But how does this link to that? So what it does is that it times 2 and times 1. But then you cannot multiply things without dividing them back. So you have to divide 2 and 1. So this cancels out into 1, and it's the same thing as we wrote. So on the top, it will be 5 factorial, and the bottom, it will be 2 factorial, which you can rewrite as 5 factorial over 5 minus 3 factorial, which is the same thing as our formula. So it will be n factorial. So from 5 objects, the n is 5, so 5 factorial. Choose k out, which in this case we choose 3 out. So it's 5 minus 3 equals 2 factorial. See, 5 minus 3 factorial, it makes sense. So it applies, let's say you have 6 objects, let's say A, B, C, D, and F. Then it will be the same thing, 6, 6. And we choose 3 out. So that's basically it. So one example will be A, B, C, D. A, B, C, D. Why do I say it like that? A, B, C, D. And we choose 2 out. So 2 blocks. Ooh, not this color. 2 blocks. First block, 4 options. Second block, 3 options. So it will be 4 times 3. You can also write it as 4 factorial over 4 minus 2 factorial. So it's P4 choose 2, basically. And then just plug in the formula. 4 factorial, 4 minus 2 factorial equals to 4 factorial over 2 factorial, which is 4 times 3 equals to 12. That's basically it. Okay? And so what this does, what you have to know is you don't have to memorize the formula. You just have to know how the formula becomes this, and then you can use it freely. You can make up your own formula. You can make up the formula by yourself, not your own formula. And basically, understand that it's n different objects, and choose K without repetition, and the order matters. These I have to emphasize because in the future videos we'll see, oh, combinations. For combinations, order doesn't matter. Then how does it happen? How do we count it? Right? So we have to remember that it's different objects without repetition, and order matters. For the next video, I'll explain what 0 factorial is, because for factorial it's intuitive. Let's say 6 factorial, it's 6 times 5 times 4 times 3 times 2 times 1. It's the all possible arrangements of n different things. But what if you have 0 thing? How do you arrange it, or how do you not arrange it? So it will be a video for next time. I hope you understand what permutation does and how it is utilized, and I'll see you in the next video. Bye bye.